Hey everybody, so we are going to go ahead and do a big ol' review of all of our PFT 119 kinesiology notes. So I'm going to go ahead and title this baby up here. We'll go ahead and do PFT 119 kinesiology of human movement. And this is our midterm review. With the W at the end, because that's how you spell review. So we are going to go ahead and go through all of our most important terms in order to make sure that everybody is prepared and feeling really good about our midterm. So the first thing we're going to start talking about is our human movement system, or the kinetic chain here. So your kinetic chain is comprised of your nervous system, your skeletal system, and your muscular system. So let's go ahead and start by talking about the nervous system. Your nervous system is going to be divided into two primary sections. That's going to be your central nervous system, right? This central nervous system, that's going to be your brain and your spinal cord. That's sort of the control center or the command center for your body. And your peripheral nervous system, which is going to be all of your cranial and your peripheral nerves. So these are all the nerves that are along, the periphery of your body. They're on the outside. Their job is to gather information and get it back to your central nervous system so that your central nervous system can execute the appropriate response. And then your central nervous system can't actually execute that response, so it has to be able to send that back down your peripheral nervous system in the opposite direction to get to the actual site. So in order to understand that, we kind of need to understand our different types of neurons. A neuron is going to be the functional unit of your nervous system. So your entire nervous system, central and peripheral, all are made up of different types of neurons, right? So you've got afferent neurons, which are commonly referred to as sensory neurons because it's a lot easier to say. And they transmit signals from effector sites to your brain and your spinal cord. So their job is to sense information and send it to your brain. You've also got efferent neurons, which is actually pronounced efferent neurons, but those are commonly referred to as motor neurons. They are neurons that transmit signals from your brain to an effector site, such as a muscle or a gland or something like that. So you would gather information with your afferent neurons that would come in, your brain would make a decision, and then it would execute the response with your efferent neurons. Now, obviously, we have to have connectors in between all of those, and that's where your interneurons come in. Your interneurons are basically connecting neuron to neuron to neuron to neuron, because you got to get information all the way from your left big toe all the way up to your brain, which is not exactly close. So those are all of your interneurons. Now, we've also got, when we're talking about that sensory information, right, we've got a lot of different types of receptors in our body. We've got photoreceptors that respond to light. We've got chemoreceptors, which respond to chemicals and smells and tastes and things like that. But the big ones that's important for us are going to be mechanoreceptors, right? Mechanoreceptors sense mechanical or physical changes throughout the body. So they're responsible for things like touch and pressure and length and tension and things like that. So your mechanoreceptors that we primarily talk about are going to be Golgi tendon organs, which are the mechanoreceptors that are responsible for sensing a muscle's tension and a muscle's rate of tension change. So when you hear the word Golgi tendon, think Golgi tension, right? They are located in your tendons, which is where they get their name. But their job is to sense the tension in your muscle and how fast that is generating tension. You've also got muscle spindles, which are responsible for sensing your muscle's length and the rate of the length change. So, those two things working together tell your body what position it is. If I've got my elbow bent like this, my body's getting a signal from the muscle saying, hey, we're at, medium tension because it's relatively bent. So, it's actually relatively low tension because it's in a bent position. And then the muscle spindle is saying, yeah, we're at about 50% max length right now. This would be 100% max length where there would be more tension. We also have one more that I forgot to add here. You've also got joint receptors. And joint receptons. Joint receptors are mechanoreceptors located in the joint cavities that are responsible for sensing pressure, changes, acceleration, and deceleration of the joints. Oh my God, I can't type. Which is why I can do this. Click. Oop, that's not delegation. Deceleration of the joints, right? So mechanoreceptors, they're in your actual joints. Their job is to, sense pressure changes. If there's like a lot of pressure, or if there's a massive acceleration or a massive deceleration, your joints are sending that information to your brain as well. So that is how all of that information coming in, the length of your muscle, the tension of your muscle, the acceleration, pressure, all of that gives you what is called proprioception, which is arguably our most important term on this entire review. But proprioception is your body's ability to understand where it is in space. My body knows that my neck is bent right now because there's a lot of tension and a lot of length in these muscles here, and there's very little tension and very little length in these muscles here. So my brain is able to interpret that information and sense its body position. So that's proprioception. It's your spatial awareness. It's your body's ability to know where it is. So then that's your entire nervous system, which is in charge of all of that. Then you've got your skeletal system, which makes up the framework for your body. That's going to consist of your bones, your joints, and all of your joint structures like ligaments, cartilage, bursa, all these special little like structures that you've got inside of your joints running throughout the body. So let's talk about the bones first. Your bones, they're going to be acting as like the levers throughout your body. Your muscular system's job is to manipulate your bones, right? And so your bones are the levers that actually get that manipulated movement to occur, right? So your bones have special little bony landmarks on them. They're going to have two that are really common called processes and depressions. Processes are special bony landmarks that are basically projections from the bone that allow your muscles to attach, and depressions are special bony landmarks that have little dents in them that allow your muscles to attach. So when a tendon, which attach muscles to bones, is going to have like its grip, it grips the skeletal system thanks to things like processes and depressions. Now you've also got ligaments, and ligaments are the connective tissue that attaches your bones to your bones. So if a tendon attaches a muscle to a bone, a ligament is going to attach a bone to a bone. So those are going to be located in your joints. Primarily those are going to be found in synovial joints, which are those really super common joints throughout our body that have lots of motion. Your ligaments attach your bones together. So they allow that axis of rotation, right? If your bones act as a lever, your joints are going to act as an axis. Now, your bones are continually going through a process called bone remodeling, which involves resorbing old bone, or if you want to think of it as like reabsorbing, that's actually a pretty good way to think about it, and the building up of new bone tissue. And so you have special cells called osteocytes, which are in charge of resorbing and building up new bone. So those two types are going to be osteoclasts, which are your bone breaker downers. Their job is to basically eat away any imperfect or old bone tissue that needs to be resorbed. So they'll eat that all, and then like they'll basically spit up the ingredients and then self-detonate so they don't keep eating your bones. And then you have your osteoblasts, which are your bone builder-uppers, and their job is to kind of come along afterwards and lay down this kind of special collagen matrix that absorbs calcium, and so that'll actually take those old ingredients from your broken up bones, thanks to your osteoclasts, and build up that new bone tissue in order to increase its density. Then you're going to have your muscular system, right? This is actually what's going to sort of manipulate our body around. So your muscular system is going to be a series of muscles and tendons that have the ability to generate internal tension, and then that is going to be what allows you to actually move your skeletal system, right? So the functional unit of your muscular system is going to be what we call the sarcomere. So the sarcomere is this really special thing that we see in muscle tissues, where you have these repeating layers of these specialized little proteins called actin and myosin. So the sarcomere is the area of town, basically, in your muscle fibers, where actin and myosin overlap each other, and they're able to slide in this process we call the sliding filament model. And so you've got actin, which is the thin filament. And actin is like this little long strand that has all these binding sites on it. And those binding sites are really attractive to this other myofilament called myosin. And myosin is this thick filament that has all these little club-like heads. And those club-like heads like to reach up and grab the little binding site and then pull. And that is the sliding that happens in the sliding filament in the model. Now, we don't want that to occur like all the time. Like we want to be able to relax our muscles and rest them. And thanks to that, we have two specialized proteins called troponin and tropomyosin, which are little binding site blockers. They live on the actin strand, and their job is to be in the way so that myosin can't reach up there and bind all the time. But luckily, whenever we create like a muscular contraction, your nervous system generates an action potential, which then makes an action potential within your muscle fiber. That's what we call a motor unit, right? Single neuron and all the fibers that it zaps. That motor unit, whenever that happens, that actually allows those binding sites to become exposed. And that is how the sliding in the sliding filament model actually happens. And so the sarcomere is able to draw itself closer and get a little shorter. Those are some specialized proteins you're definitely going to want to review. We've also got our different types of fibers. You know, like yours truly tends to be a pretty long, skinny person. So I tend to be more of a type 1 athlete, although I certainly have my type 2 fibers, just like anybody else. You know, giant bodybuilders gonna have plenty of type 1 fibers as well. But the two types that we've got type 1 fibers and type 2 fibers. Your type 2 fibers are your fast twitch, and your type 1 fibers are your slow twitch. And so when they're slow twitch, they're primarily used for like endurance type activities. So think like running, right? Long distance running. They tend to be smaller in size. They have a larger number of capillaries, more mitochondria, and more myoglobin, which are all things that use oxygen. Type 1 fibers are particularly good at our aerobic metabolism. Then you've got your type 2 fibers, which are referred to as fast twitch fibers. They tend to be used for like heavy strength, really powerful contractions, right? So they're larger in size, which, you know, because they're larger in size, they're going to have more cytoplasm, which means they're going to be a little bit better at anaerobic metabolism. So they don't have quite as much mitochondria, they don't have as much myoglobin, and they don't have as many capillaries. So they may not be as good at aerobic activity, but they're very good at anaerobic activity thanks to their size and cellular plasma. So then in our type 2 fibers, we've got type 2A and type 2X. These are like little subcategories. You've got the type 2A, which are your high oxidative type 2 fibers. They have a little bit more oxidative enzymes that give them a little bit more endurance compared to your type 2X fibers, which are your true fast twitch fibers. They don't have quite as many oxidative enzymes, so they tend to be really good at like, this is the truly explosive type muscles, right? When you think of like an Olympic powerlifter who's going to get an incredible amount of weight up once, that's a type 2X athlete. But if you think of like maybe a football player that needs to be able to get on the line, create like a whole bunch of force and push some linemen back, and then be able to do it again and again and again throughout an entire game, that's going to be more of a type 2A athlete, right? They're creating a lot of force, but they're doing it with a relatively higher amount of endurance compared to type 2X, although they're not going to have as much endurance as a type 1 muscle fiber person. So then your muscles are going to be arranged in such a way, you know, we have to be able to make contractions, right? And so if we were able to contract a muscle in one direction, we have to be able to, you know, uncontract it or contract it in the opposite direction, right? And so, you know, we have terms for those. We're going to refer to them as agonist muscles if they are the main muscle doing a particular movement, right? So an agonist muscle is like a prime mover. So if I'm talking about elbow flexion, which is this motion here, my bicep is going to be the agonist because it's the main muscle that's doing that job. And then we've got antagonist muscles, which are muscles that work opposite of your prime movers. And they go in the exact opposite direction in order to get you back to, you know, a resting position. And so those muscles, right, if I'm talking about my bicep as an agonist, then my tricep would be an antagonist whenever I'm describing elbow flexion. However, any muscle can be an agonist or an antagonist or a synergist, which we'll get to in a second, depending on what the action is. If I start explaining, you know, if I start describing elbow extension, now suddenly my tricep is the agonist and my bicep is going to be the antagonist. So it depends on what the motion is that you are describing. Then you've got synergist muscles. Their job is to assist prime movers. And you've got stabilizer muscles, which are going to stabilize the body during your particular movements. Your core is a really good example of a series of stabilizer muscles. When you're doing functional movements, your core is kind of holding to keep your spine in place. So now let's go ahead and talk a little bit about like things like flexion, extension, and stuff like that, right? So we got to understand biomechanics, right? Biomechanics is going to be the science concerned with how our body actually interacts with the various forces of everyday life. Those could be internal forces like your body itself, or it could be external forces like you trying to lift a dumbbell. So first, we'll talk about planes of motion. So planes of motion are these three imaginary planes that divide the body into different sections. You're going to divide yourself into the sagittal plane, which is going to cut you down the middle and divide you into left and right halves. And you're always going to move along your plane. So if the plane's dividing me this way and traveling infinitely that way and infinitely that way, I'm going to move along the plane doing motions like this, right? Front to back motions or back to front motions. Then you've got frontal plane, which is going to divide you into front and back halves. So the plane's going to move infinitely in this direction. Those are going to be motions that are like side to side, right? Something like this would be frontal plane. And then the transverse plane is going to divide me into upper and lower sections, right? And so I'm going to move along it like this during rotational movements or during twisting. So those are our planes of motion. We've also got different types of contractions that our muscles can do. Concentric contractions occur when a muscle is generating more force than a resistance, right? So if I've got a 10-pound dumbbell and I generate 11 pounds of force, which is more than the resistance, my muscle is going to shorten. That is going to be a concentric contraction. Then if I were to have that dumbbell and generate 9 pounds of force, which is less force than the resistance, my arm is going to relax and lengthen. That's an eccentric contraction. And then isometric, if I've got 10 pounds and I generate exactly 10 pounds of force, that is going to be contractions that are equal to a resistance. And so your muscle length will stay the same. You can think of concentric contractions as honestly like the squeezing part. You can think of eccentric as the relaxing, and you think of isometrics whenever you're stabilizing. So that's force production, force reduction, and force stabilization. Okay, let's go ahead and look at our joint actions here. So talking about the sagittal plane, you've got a few different movements that only occur in the sagittal plane. That's going to be flexion and extension. Flexion is a movement where the angle between two joints is going to decrease. So if I went from 180 up to 90 up to 45, right, that angle is decreasing. That's going to be things like elbow flexion or spinal flexion or things like that. Extension is where the angle is increasing, so from 45 to 90 to 180, right? That's going to be extension. Then we've also got dorsiflexion and plantar flexion. Those are special to the ankle. Dorsiflexion is when you're pointing your toes away, and plantar flexion is when you're pointing your toes away, so you're moving them inferiorly, which I have these backwards on here. And then plantar flexion, sorry, I can't type and talk at the same time, apparently. Dorsiflexion is going to be moving your toes superiorly. That's going to be pulling your toes back towards your face. And plantar flexion is when you're planting your foot. You're going to point your toes away. So your toes are going to move inferiorly. You got frontal plane actions like abduction and adduction. Abduction is a movement away from your midline. Adduction is a movement toward your midline. You can think of it as like my arms are being abducted by aliens, right? You've got lateral flexion, which is special to only the spine. It doesn't have an opposite here, but basically your spine can laterally flex either left to right or right to left. You've got eversion, which is also special to the ankle. Eversion is when you are going to show the outside of your foot to the outside of your body. The bottom of your foot to the outside of the body. Inversion is going to be when you rotate like this and show the bottom of your foot to the inside of your body. So those are all of your frontal plane actions. And then you've got your transverse actions, which are going to be things like internal rotation. Internal rotation is when you are rotating towards the inside, and external rotation is when you're rotating to the outside. So if I rotate my shoulder in like that, and I rotate my shoulder out like that, this is internal rotation, and that's external rotation. You've also got horizontal abduction and horizontal adduction. And so similar to adduction and abduction, except that it's moving along this plane instead of this plane. And so horizontal abduction would be moving from front to side, and horizontal adduction would be moving from side to front. And then you've also got some special terms, pronation and supination, which is rotary movement involving either force production or force reduction. Pronation would be when you are rotating a door handle like that, and supination would be when you are rotating a door handle like that. You can think of it this way, give me soup. It's the easiest way to remember it. Then you've also got left-right rotation, which is just happening in the spine there, either moving to the left or to the right. Now we got a couple special ones here that are not sort of dictated by the planes, but you've got your scapular actions, and your scapular actions just describe how your scapula actually moves. So you've got scapular retraction, which is going to be when your shoulder blades move closer together, right? If you're drawing your shoulder blades like that, back like that, they are coming closer together. That is scapular retraction. And when your shoulder blades are moving farther apart, right, maybe something like that, that's going to be scapular protraction. So if they're moving further away from each other in the back or moving closer to each other in the back. You've also got scapular elevation, which is when you're raising your shoulders like this, and scapular depression, which is when you are raising pushing your scapula down like that. So if your scapula is going up, it's scapular elevation. If your scapula are going down, that is scapular depression. Now, lastly, we are going to blast through some anatomic terminology, which are basically these terms that we use in order to understand certain locations on the body. So the anatomic position is going to describe all of these. That is when you are standing with your feet hip width apart, toes pointing forward, arms at your sides, palms facing forward. And I know that's not how we normally stand, but that is the anatomic position. So whenever we're describing something, it's always in reference to where it is on the anatomic position. If you were standing upside down, your head is still superior even though it's below everything, because I'm referencing the head in the anatomic position. So these terms are going to be superior and inferior. Superior is going to be above a point of reference. Inferior is going to be below a point of reference. Medial and lateral. Medial is going to be closer to the center. Lateral is going to be closer to the midline. Lateral is going to be further from the midline. So medial is towards the inside of the body and lateral is towards the outside of the body. You've got proximal and distal. Proximal is going to be closest to the center or a point of reference, and distal is going to be further from the center or a point of reference. So where your sagittal plane meets your frontal plane, where your sagittal plane meets your transverse plane, there's where that X kind of meets, that's your dead center. Anything closer to that is proximal, right? It's within proximity. And distal is, it's farther away. There's a lot of distance between the 2 points. Generally, we are only going to use the terms proximal and distal when we're describing something on the legs or arms. So when you're talking about your appendages. So in this case, right, we're talking about getting back to my center. So my wrist is more proximal compared to my fingers, and my fingers are more distal compared to my wrist. But the wrist is more distal compared to my elbow, but it is still more proximal compared to my fingers. So those are those terms there. Then we've also got anterior and posterior. Anterior is going to be on the front of the body. Posterior is going to be on the back of the body. Your face is anterior and your booty is posterior. We've also got contralateral and ipsilateral. Contralateral is going to be referring to anything that's on the opposite side of the body. It contradicts, right? And then ipsilateral is anything that's on the same side of the body, right? So my right hand is contralateral to my left hand, but my right hand is ipsilateral to my right foot. And then you've got prone and supine. Prone is going to be face up, and supine is going to be face down. So if my palm is face up, that's supine. If my palm is face down, that is prone. So that is our super duper review of everything for our PFT 119 midterm. If you guys got any questions, as always, please shoot me an email or text or give me a call. But we'll kind of have this video up, and you guys are going to want to log into your canvas.instructure.com site. That sentence got away from me. You're going to want to log into Canvas and check for the midterm today. It will be 30 questions covering all of this content. So We will see you guys next time.